Today in Physics with Beth and Hannah and Lindsay, we're going to teach you about sound. Sound moves in transverse waves. These waves have a crest, which is the high point, a trough, which is the low point, and a wavelength, which is the length between two crests or two troughs, and an amplitude, which is the height.
The speed of sound in air is about 340 meters per second. If you are standing on a cliff and yell hello to someone down below, the sound of your voice will travel at 340 meters per second. However, the speed of sound can change depending on the medium it travels through. Sound travels faster as the medium becomes more dense. This is because the molecules in more dense mediums are packed closer together.
In liquid, molecules are closer together than in air. Sound travels 1,484 meters per second through water. If you scream at the fish underwater, your voice will travel faster than in air. Through a solid, sound travels the fastest. Additionally, sound travels slightly faster in warm air than cool air because the molecules are moving around.
Lastly, transverse waves can be illustrated by moving a string up and down quickly. In this case, the speed of the wave depends on its frequency and wavelength. The speed is also equal to the square root of the tension, force, divided by the density of the string mass divided by the length.
Now we're going to work out a couple of sample questions. Number 1. A transverse wave on a string has an amplitude. A tiny dot on the string is colored green. As one cycle of the wave passes by, what is the total distance traveled by the green dot? In one cycle, the dot travels the entire length of the wave, up, then down, then up again to its starting position. Since the wave's amplitude is A, therefore the dot will go 4A as it goes up the wave, and then back down, and then returns. Sample question number 2. Two strings have the same mass and the same length. The tension in string 1 is 3 times the tension in string 2. The speed of a transverse wave on string 1 is how many times the speed of a transverse wave on string 2? To solve this, we will plug the values we know for string 2 into the equation. The mass and the length are the same on both strings, so we can give those values 1. The tension in string 2 is 3 times as great as the tension in 1, so we can plug a 3 in for that. Therefore, the answer is the square root of 3. Thank you for watching, Chuckleheads. See you next time on Physics with Hannah and Beth and Lindsay.